Active cylinder management allows for a reduction in fuel consumption. This is achieved by the automatic switchover to the fuel-saving two-cylinder mode. Depending on the engine power requirement, two cylinders are either activated or deactivated. What's the basic principle of active cylinder management? A rowing boat of 4. Here, muscle force is required, but the principle is the same as with cylinder management. In this example, the rowing boat is to maintain a constant velocity. In case of headwind and countercurrent, all 4 rowers have to move the boat together. A cox controls the speed and the strokes. If the boat moves with the current and without headwind, the 2 center rowers can pause. This again is coordinated by the cox. In the case of cylinder management, the engine control unit adopts the role of the cox. The current represents the oil temperature, the headwind is the torque, and the rowing speed the revolutions. The cox's function is taken over by the lambda control. As is possible in the boat for 2 rowers to pause, under certain conditions, it's also possible for a 4-cylinder engine with active cylinder management ACT to switch over to the 2-cylinder mode. This Volkswagen TV training informs you about the mechanical aspects and engine-specific processes of the active cylinder management. Active cylinder management is applied in the 4-cylinder TSI inline engine with the following technical data. Displacement of 1.4 litre. Output of 103 kilowatts. Torque of 250 Newton meters. Fuel consumption of 4.7 litres per 100 kilometers with the 6-speed manual gearbox and 4.5 litres per 100 kilometers with the 7-speed DSG. The multifunction display shows the driver when driving in 2-cylinder mode. When driving in 4-cylinder mode, the display will clear. In the new European driving cycle, in short NEDC, active cylinder management reduces the engine's fuel consumption by up to 0.4 litres. In city driving, the engine consumes up to 20% less fuel. The engine with cylinder deactivation is characterized by 4 actuators attached outside. How do they work? There are external sliding grooves on the 2 assembled camshafts at cylinders 2 and 3. This is where the cam pieces with inside sliding grooves are attached. The teeth of the cam pieces and the camshafts allow the cam pieces for the cylinders 2 and 3 to be moved in a longitudinal direction. And that's how sliding works. Depending on the sliding direction, the corresponding metal pin of the actuators drops into the designated sliding groove. The cam piece inevitably slides in a longitudinal direction, and the metal pin is returned into the actuator by means of the reset ramp. Exhaust is emitted. The exhaust valves are closed. Fresh air is taken in and the inlet valves are closed. Injection and ignition are deactivated. After the cylinder valves have been deactivated, the roller rocker fingers run on the zero lift cam. Therefore, the valves are no longer active and injection is stopped. The cylinders now only run unfired. The air enclosed in the cylinder acts as a spring. At higher loads, the other metal pins are actuated. They slide the cam pieces in the opposite direction. Now, the roller rocker fingers run on the standard lift cams again, and all 4 cylinders are fired. With active cylinder management, the engine can be switched from the 4-cylinder mode over to the 2-cylinder mode. This is done under the following conditions. The engine speed is roughly between 1,250 to 4,000 RPM. The engine torque is maximum 100 Newton meters. The oil temperature is at least 10 degrees Celsius. The coolant temperature is at least 30 degrees Celsius. The lambda control is active. The deactivation process takes place within 1 camshaft revolution and takes only a few milliseconds. To ensure that the driver does not notice the deactivation procedure, this is carried out in 5 phases. Phase 1. The throttle valve is opened further so that cylinders 1 and 4 are supplied with sufficient air after deactivation. Furthermore, all cylinders together receive about twice as much air as is actually required for the 2-cylinder mode. In order to avoid a sudden increase in torque after deactivation, the ignition time is pushed in the late direction. Torque thus remains constant. Phase 2. The exhaust gas is expelled. The engine control unit actuates the exhaust cam actuator. The cam pieces are adjusted so that the roller rocket fingers run on the zero lift cam. The exhaust valves are no longer actuated. Phase 3. Injection and ignition are deactivated. Phase 4. Fresh air is taken in and trapped. It works like a spring which supports the downward movement of the piston. Phase 5. The ignition points of cylinder 1 and 4 are adjusted in the direction of early. Optimal effectiveness is achieved. If in the 2-cylinder mode a higher torque is required, when accelerating for example, the engine switches over to the 4-cylinder mode. This is also done in 5 phases. Phase 1 of the activation process. The engine control unit actuates the exhaust cam actuators. The cam pieces are adjusted so that the roller rocker fingers run on the standard lift cam. The fresh air is pushed out via the exhaust valves. Phase 2. The injection quantity of the active cylinders is increased in order to regulate the gas mixture. Lambda 1 thus exists at the catalytic converter. Otherwise, the fresh air would make the exhaust gas value exceed lambda 1. Phase 3. The engine control unit actuates the inlet cam actuators. The cam pieces are adjusted so that the roller rocker fingers now also run on the standard lift cam on the inlet side. Fresh air is taken in. Phase 4. Now, injection and ignition are activated again. In order to avoid an increase in torque during the cylinder activation, the ignition time is pushed in the late direction. Phase 5. For the same reason, the throttle valve is closed further. Finally, the ignition point for all cylinders is adjusted to the early position. Optimal effectiveness is achieved.